In 2020, the screen time for heavy users is up to 17.5 hours per day, and for non-heavy users, it goes to an average of 30 hours per week. The screen time has been between more than 60% to 80% than that before the pandemic. As we can see the increasing screen time during the pandemic, due to the stay-at-home orders and other impacts, we anticipate that there will be an increasing healthcare needs both for people's physical and mental health problems. In 2019, $225 billion was spent on mental health treatment and services, and between 2019 and 2020, there is an 21% growth in mental health claims, and the overall spending on mental health claims increased by nearly 25%. As we can see the increasing cost in health concerns, we want to design technology to help people live independently at home as long as possible and help them have a positive quality of life. One way is to understand their behavior patterns and assess behavior changes as a view to applications to personalized healthcare. With massive amount of sensor data being collected everywhere, such as from our computers, our phones, and smartwatches, we can now develop innovative algorithms to have a much greater understanding of complex behavior and behavior changes. We first investigate behavioral norms both at a population level and among subgroups, so that we can predict behavioral features of individuals within a group. We have already developed an initial model by analyzing the cursory mouse movement data. For example, people with cognitive decline may move the computer mouse in a different way, may be slower to effectively navigate, may be more curved or looped, or sometimes less direct or less efficient to approach to reach to the target to click it, or greater variability in the length of pauses made between successive movement. This is what the current researchers have been exploring for each observed movement separately. However, we construct machine learning-based models that combine all this information together into one model to offer the potential of capturing health problems at the early stage. What we did was combine both spatial and temporal feature information together. Spatial means where on the screen. Temporal means when and how long of an event, such as when we click, how long we move from the current location to the target location. We think the screen as a grid with cells, and each cell has a fused spatial temporal information. Our model can include all available information while meeting real-life situations. Should the algorithm show a significant improvement of early detection and intervention, the community with health concerns will benefit from this study.